Hey, welcome back. Last time I had asked you guys to answer these questions on your own, and I said we'd pick up here when we came back next time. Okay, the lowest electromagnetic energy waves are radio waves, and the highest is gamma radiation, like what comes from nuclear reactions and nuclear waste. Okay, photon is the electric particle that causes the electromagnetic waves. An electromagnetic field and what creates them, okay, electromagnetic radiation is created when an atomic particle, such as an electron, is accelerated by an electric field. So remember, the electron has a negative charge. It's in this electric field, and the electric field has positive and negative pull on it, and it causes it to move, okay? And it starts to move, and oscillating means it moves back and forth. So the movement produces an oscillating back and forth electromagnetic field, which travels in a bundle of light energy called a photon. And so it's that particle moving out in, but it's still going back and forth, so it's that wave-like energy. What is the electromagnetic spectrum? It's the range of electromagnetic energy that goes from big radio waves to tiny high-frequency gamma radiation. So it's that entire spectrum. Radio waves aren't dangerous at all. Gamma radiation is very dangerous. Okay. Visible light, and the reason why it's called visible is because the only one that can be seen by humans. Okay. What are two uses of radio waves? Well, radio is obvious, that's why they're called radio waves. And then MRI, magnetic resonance imaging. Infrared waves give off energy that's felt as heat or thermal energy. Okay. Behavior of visible light. So it's kind of like covered sort of the theory of this stuff, and now like, okay, what goes on? Okay, so visible light's the only part of the electromagnetic spectrum that can be seen by humans. And remember we said with electromagnetic radiation, when it hits something, it can't pass through, it's either absorbed or reflected. And sometimes it can pass through, which is when it's going to refract. So electromagnetic energy doesn't do anything to it. When it hits something, and then it's either absorbed or reflected. Okay. Or it could go through. Okay, so transmission is like light passing through an object, and that's where we're going to learn about refraction. Okay, as it bends as it goes from one medium to another. So that's why, like if you look at water, we said that the spear fisherman, the fish would appear in a different position. Okay. Absorption is when it's absorbed into the medium. So like if you go outside in the sunlight and you're wearing dark clothing, the material heats up because it's absorbing energy from the sun. And if it's reflecting, it bounces off. So like on a mirror, or people put those shiny things on their dashboard to reflect the energy back so it doesn't get into the car and get absorbed and make the car hot. Objects must reflect light in order to be seen. If they just absorb light, we can't see them. The color that we see on things is the color of light that's being reflected and coming back to our eye. Okay, you see the color that is not absorbed. So it's the one that's being reflected. Okay, so this is a piece of crinkly foil. Okay, the wrinkly foil is so black you cannot see it. It's absorbing all the light and none is being reflected. So when we say like you see what's reflected, okay, in this case, nothing is being reflected. All the light's being absorbed. So even though this is this black, which is this special nanocarbon paint they have, okay, it's so black that you can't see that it's painted on this wrinkly foil. It looks like it just made the foil disappear. Shiny hard surfaces reflect. So remember, we said things can either be absorbed or reflected. So like this jet is shiny and it has hard surfaces and it reflects electromagnetic radar. If you want to make something disappear, you use dark, soft surfaces, the radar or the electromagnetic energy waves, it helped the bomber become stealth and invisible to radar. So a lot of what we're learning, even those like stealth aircraft is super high technology, the reason why they're not silver and the reason why they're black like this is because they want them to be absorb electromagnetic energy, not reflect electromagnetic energy. So, and then this is a B-1 bomber, and my daughter actually works at Air Force Base where they have bombers. And so at a special air show, you could get close enough that you could see the surface of this. It's soft. It's not hard like this metal here. So it's soft and it's dark so that it absorbs energy rather than being shiny and hard and reflective. Okay. Now, when the light hits something, okay, and it can't pass through and it's going to be absorbed, that's because the material is opaque. So they don't transmit light. It's either absorbed or reflected back. And an example of things that are opaque is you, a book, a car, anything that makes a shadow. Translucent, you see, I covered up the word translucent with something that was translucent. So like we can still see the word, but it's not as clear. Okay. These windows, okay, light passes through the window. I mean, you can see the other side. You can see there's a man standing there, but it's not a clear image. So it's kind of a blurry image where some of the light passes through, or like this frosted glass on this other window. These are called translucent because they only allow some of the light to pass through. And then finally, something that's transparent allows almost all the light to pass through. Only a little is absorbed or reflected. So transparent, nothing is perfectly transparent. Nothing allows all of the light to pass through, except maybe a vacuum, it's a vacuum space. But even the clearest window reflects some of the light. Right? So if it's very, very, very clear, we say that it's transparent. Now, there's this little video that we're going to take a look that explains transparent, translucent, and opaque. We're going to be taking a look at transparent, translucent, and opaque objects. This first object is a piece of glass. It's going to allow almost all the light to pass through the object. We can see the beam of light going right through the glass, and it comes out the other way, and it's not broken up. Almost all of it passes through the glass. This object is classified as being transparent. In the next example, he's going to shine the light at this piece of wood. You can see that some of the beam is being reflected back towards his eyes. It's a diffuse reflection, but the reflected light allows him to see the piece of wood. On the other side of the wood is a complete shadow. That's because none of the light is going through. All of it is either being absorbed or reflected, and the reflected light is bouncing back to his eyes so that he can see the piece of wood. Finally, with this translucent object, you can see that the beam of light goes through the translucent object, but on the other side it's broken up and it's diffused. A translucent object breaks up the light, doesn't allow all of it to pass through. Some of it's reflected back to him so that he can see this. This might be an example of wax paper. Now, as we said, when the light hits something, it could either be absorbed or reflected. So like an opaque object absorbs some of the energy and then it reflects like what you see. So a piece of wood in the little video that we just watched was opaque. Some of the light was absorbed by it and it only reflected brown color back. Okay, so our notes tell us that reflection is a light wave strikes an object and it bounces back off of it. And sound waves does the same thing. We're going to take a quick look at this Bill Nye thing on echo. Finally, this is a good demonstration of an echo, which is a sound reflection.
Listen up. When I yell, the sound waves leave my mouth and hit that hard surface over there. Then they come back to me. Waves! 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 The waves keep their shape even though they bounced. Echoes! 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 Cool, yeah? Say it! What?
Earlier in the last unit, we talked about the law of reflection. It says the angle of incidence is always equal to the angle of reflection. The angle of incidence is formed by the wave striking a surface in the normal. So we have the incident ray coming in. This normal is a dotted line perpendicular to the reflective surface, and it's imaginary. So like if this is a mirror, there's actually not this line sticking out of the mirror, hitting in the face. The angle of incidence then is this angle between the incident ray and the imaginary normal that is just this perpendicular line that people imagine to be there so that they can measure this angle. And then the angle of reflection is the angle formed by the reflected wave and the normal. So then it hits the mirror and it bounces off. You have the reflected ray. And then this is the angle of reflection. The relationship between this angle and this angle is that the angles are equal. And then again, the normal is this perpendicular line, this line perpendicular to the reflective surface. This is what causes images in a mirror to be reversed. So if you regular reflection is a reflection of light on a smooth surface. Preserve the image, but it's reversed. So if we trace this line that's here, okay, it's coming in and then it bounces, okay, and it was on the outside, but now it's on the inside. So when it comes back, it's, switch sides. And this one that was on the inside is now on the outside. So this is why you look backwards in the mirror. So this is called a regular reflection. It's when the light law of reflection is applied because the surface is completely smooth. So all the light rays come in a line and then they bounce off at perfectly the same angle. And they all come back out, still parallel to each other. It's just on reverse sides. And then a diffuse reflection is reflecting light on a rough surface. So diffuse means to break something up. So like diffusion. Well, last year when you learned about diffusion and something spread out throughout a cell, okay? So, or when we fuse something together, it means to join. So if you defuse, it's unjoined. So here it shows 4 light rays coming in and they're all parallel to each other. And then they hit this rough, bumpy surface and they defuse, they break up, they come out all irregular. This is something like, hitting a piece of material. This is why my shirt is not immune, because it's a diffuse reflection. Only some of the light's being absorbed, some's being reflected, but it's all broken up. Refraction is still the change of speed of a light wave when it passes from one material into another. Okay, so here's 2 examples of refraction. So I'm going to stick with this one first. You got this light wave coming in, it hits a piece of glass, okay, it slows down, and the waves bend. This is also what causes like a mirage. Okay, the road has very, very hot air, because you know how hot roads get in the summertime. The sunshine is out here, so the air right by the road expands. When it expands, it becomes less dense. Remember, this is also how a convection current starts. So it expands and it becomes less dense. The air above is more dense and it's cooler. So this is going to do the same thing. It refracts light as the light comes through here because of its bending, because as it changes from like dense air to the less dense air, it bends, and that's why it looks like this road is wet. A prism separates light into the visible spectrum through refraction. So just like this light is bending here, okay, when the beam of white light hits the prism, okay, it bends and it separates into the wavelengths because the different wavelengths bend more. So the shorter frequency violet light is bending more than the lower frequency red light, and then so on through the spectrum. So we got orange, red, orange, yellow, green, blue, indigo, and violet. Okay. This is also what causes a rainbow. When the light goes through the little water droplets in the air, okay, it changes speed as it hits the medium, just like it changes speed when it hits the prism, and as it goes through the raindrops, it's part of the visible spectrum. Also, some of the energy when it hits the side of the raindrop gets reflected back and gets reflected down. Okay, we're going to stop here. I want you guys to answer these questions on your own, and we'll pick up here when we come back next time. I hope you're having a great day, and we'll see you soon.